So looking at this structure, the question is which functional groups are present in this molecule? Now, I will tell you that there are some question bank questions like this that don't necessarily include all of the functional groups that are present as answer choices. So this one does, but just keep that in mind that not every functional group present in a structure might be represented. But given this structure, what do you guys think? Anyone want to make a guess? Okay, I've got a vote for C. Any other votes? Yeah? Got a vote for A. Who else? Yes. Okay, got a vote for B. Who else votes for A? Anyone else? Any other votes for B? Any other votes for C? Okay. Okay. Anyone else want to weigh in with their guess? Okay. So we've got, basically, if you look at the answer choices, we've got a choice between carbonyl and carboxyl. Okay. We've got a choice between ether and ester, and we've got a choice between nitrile and amine. So this also, you'll notice, is a sort of a combination of a skeletal structure with like a condensed structural formula in the bits that aren't just carbons and hydrogens. Okay, so the oxygens and occasionally a methyl group, or here we've got a carbon and a nitrogen bonded together. They're not going to give you a full Lewis structure for any of this. So you have to be able to look at carbons and oxygens and nitrogens and look at where they are relative to each other. Okay. So those of you who picked C, somebody tell me where the carboxyl group is. Right here? Ah, okay. Okay. Somebody who picked A, tell me where the carbonyl group is. Amaya, go ahead. Right here? Yep. Okay. Okay. So that's one dissension here. Somebody else who picked C, tell me where is the, actually, somebody who picked C or A, tell me where the ether group is. Yeah, Asanina. This one? Yeah, okay. Somebody who picked B, tell me where the ester group is. Anyone point out an ester group? Yeah? Oh, you meant to pick A. Okay, we're gonna move this up here. Okay. So we're gonna say that everyone is in agreement that this is an ether group. Good. Okay. So we're gonna cross out B and D, and then somebody who picked C, tell me where the amine group is. Okay. Okay, yeah. So when you see something like this, if it's an amine group, it would have the two hydrogens on it. So just like you have a methyl group or here, it would say NH2 in this kind of structure. Okay, and it does not, which means that this is not an amine group, right? What is this? This is a nitrile group. Okay, so that's going to be like that. Okay, so A is the correct answer, which means that this is not a carboxyl group, but this is a carbonyl group. So we have carbonyl, we have ether, we have nitrile. What is this if it's not a carboxyl group? What's going on with this oxygen over here? Amaya? It's another ether, yep. So this is basically, if we cut that out. All right, if we move that methyl group so that it's bonded to the oxygen, you can see that the oxygen has two bonds, one to the carbon in the ring structure and one to the carbon in the methyl group. So we have two ethers, one carbonyl, one nitrile. Okay. I'm going to give you some more practice with this. You'll get some practice sheets tomorrow. Yes? Because there's no, if it was, say, an amine group there coming off the ring, it would say NH2 the same way that if you have a methyl group coming off, it says CH3 in this structure, and it doesn't. So it's just a carbon bonded only to a nitrogen. So the carbon is bonded on one side to the ring structure, and on the other side to the nitrogen. Remember, the nitrogen always has a lone pair. So in order for the nitrogen to be hanging out here by itself, it has to be a triple bond to the carbon. Okay. And that's how that will be written in a condensed structural formula as well. It'll just say CN. They don't always write in the double and triple bonds in the condensed structural formulas. They did in the packet that we looked at for the alkanes and alkenes. But in a structure like this, it won't necessarily show you everything. They won't put the lone pairs on the oxygens and rather the nitrogens. So if you see an N hanging out there next to a C, if you see a CN next to each other, just by themselves without any additional branching or chain going on, then that's going to be a nitrile group. Okay. So you'll get more practice with this tomorrow. Yes. What? It will be. Yes, I haven't posted the Canvas course yet, but it will be on Canvas along with the videos, the screencasts. So yeah, I'll get those Canvas courses published tonight so that it'll be up for tomorrow. Okay. Any other questions about this? All right. So let's start naming our classes and our functional groups in our study guide, page 8. We already talked about this first one. I just erased it for first period. So this is a halogenoalkane. And this is a chloro group. The chlorine is the functional group. Not really much of a group. It's a functional atom, I guess. All right. So, Katie, what's this one? It's an alkene. And where is the functional group? Yeah, just the double bond. Yep. That would be an alkenyl group. Alkenyl. Okay. Winnie, what is this one here? What'd you say? Sorry, it's hard to hear it, and there's a difference between the two. Amine group? I'm gonna have to ask you to take another look at that. Yeah. It's an amide because the functional group, you're right that there's an amino group here, but there's also a carbonyl group. And together, this whole functional group is, if I remember correctly, called a carboxamine. Is that right? I never name the functional groups when I'm thinking about them, so yeah. So that's going to be an amide. Yep. All right. Abron, how about this one? Okay, it's an alcohol. What do we call the functional group? Hydroxyl. Yep. And there it is right there, our OH. Alex, what about this one? Yep. It's going to be an amino group. So when you have something like an OH or an NH2, you have to make sure to look to see whether it's next to a carbonyl group, because that changes what it is. Right? Oh, and let me just formally, because I didn't do this yesterday, welcome Lily and On to the 5th period crowd. Happy to have you. So On, you're up next for this next one. Yeah, this is a carboxylic acid. And that's going to be a carboxyl group. So make sure that when you see, same thing in reverse, when you see the carbonyl, make sure that you know what it has next to it. So does it have a hydrogen? Does it have a hydroxyl? Does it have just another part of the carbon chain? Those are 3 different functional groups that include that. Actually 4. There are 4 different functional groups that include the carbonyl double bond there. All right, Lily, you are up for the next one. Yep. Okay. That's our carbonyl functional group with just a hydrogen on the end. And we remember that because aldehyde has an H in it. Right. Arseni, what's this next one? This is an ester. Good. And here, again, we've got our carbonyl, but we also have the oxygen going along with it. Okay? Question, or are you just resting your hand? Okay, just want to make sure. All right. Amanda, what is this one? Yep. This is an ether with that oxygen in the middle of the 2 carbons. Aznina, what's this one? This one. Oh, okay, no worries. This one? Look again. Does that nitrogen have things coming off of it other than the carbon? If it doesn't, then that's a nitrile. Yep. You're right. This is tricky, guys. This is why I was suggesting flashcards, or at least online flashcards. Yep. Because it takes some practice getting to recognize these different things. It's like, okay, it's got an oxygen, but what if it has an oxygen and a nitrogen? Well, what if it has two oxygens? What if it has, where are the two oxygens? So it takes a little bit. Amy, what's this next one? Here. Yep, it's just an alkane. Oh, and let's circle that nitrile group. Just an alkane, there's not really anything to circle because the whole thing is an alkane. If it doesn't have any double bonds, it doesn't have anything other than carbons and hydrogens, it's just an alkane. Kathy, what's this one? It's an arene, yep. And what is that functional group called? That's called a phenyl group, yep. Now, I want to point out that this ring structure can be drawn with the alternating double bonds or the circle, but you wouldn't consider in our warm-up, you wouldn't consider these rings to be phenyl groups because they're part of the integral structure of the molecule. If you had a ring coming off somewhere and just being out by itself, that would be considered a phenyl group. Okay. All right. Sam, what's this one? It's going to be an, oops, I don't know how I got orange there. This is an alkyne. Just make sure you're careful with those enes and ines and anes. And Angel, what's our last one? Yep. And here's our carbonyl group there, in between two carbons. So that makes it a ketone. All right. Good practice. What I want to do next is talk a little bit about naming these. So go ahead and turn to page 9. At the top is the just the stem names that we've already covered. I did want to touch on this idea of cyclic structures. So those of you that did the models challenge with the isomers of acetone notice that you had a couple of cyclic structures in there if you got all 9 of the isomers. But this is possible when you have the carbons just looped together in a ring. And so you can have rings going from 3 to 6. And the way we name these is we put a cyclo before the stem. So this would be cyclopropane. This would be cyclobutane, cyclopentane, cyclohexane. Okay. And then if there are substituents on that, then you would name them. And there's some particular naming when we're talking about a ring, which I don't think you need to. Yeah, I think it's HL curriculum to cover that. So you're not going to have to name anything complicated within a ring structure. Okay. Now, page 9 and 10, bottom of page 9 and into page 10 starts some branched alkanes and then some alkenes. And then page 11 has some alkynes. The alkynes are named just the same way as the alkenes. They have the, you have to indicate if the molecule is long enough which carbon the triple bond starts on. But otherwise, it's the same as naming the alkenes. Okay. I actually want to move on from there. So what I will do, I will suggest that you practice with naming those compounds. And after we get through this section, I'm going to go ahead and publish the answer key to the packet so that you can check your naming on all of the different compounds in this section. And then you can always ask me if you have questions if something doesn't make sense. Okay, so let's skip to page 11 and start talking about some of the other functional groups and how we name them. So we're going to start with our alcohols. It gives us a general formula for alcohols. That is kind of assuming that the rest of the chain is an alkane chain and doesn't have double bonds. When you start also adding double bonds in, then the general formula doesn't work out so well. But here, in these examples, we're only seeing single bonds. So this is where we're going to start using that suffix, well, not start, but continue using the suffix the way we did for the enes and the ines, where we're going to name the root, the stem. We're going to add an an, en, or yn based on whether or not it's all single bonds, if the chain has a double bond or has a triple bond. So if it's all singles, you're going to have like methan instead of methane, because you're also going to add the suffix that indicates it's an alcohol, which is ol. Okay. So for the alcohols, the suffix is the end of the word. All right. So methanol, ethanol, and then methanol and ethanol, it doesn't matter. You don't need any numbers because there's only one way that the structure could work, because it's going to be on that one carbon, or it's going to be on the carbon that we're going to label carbon 1, right? We get to propanol, and now we have two versions of propanol. One where the hydroxyl group is on the end, and one where it's in the middle. So now we have to start sticking a number in there. And it's going to be the same way that we used to designate the double bonds in the alkenes. We're going to stick it at the end, right before the suffix that tells us what the functional group is. So this would be propan 1 all. So we're sticking the 1, we're saying the all part is on carbon number 1, versus this one, which is propan 2 all. Okay. Now, I'm going to write a couple more names here that I don't want you to get confused about. I want you to use the names that I just wrote, okay? Because this is the correct IUPAC naming format, all right? But you will often see this referred to as 1-propanol, and this referred to as 2-propanol. That's an older way of referring to them. And this is also referred to as an even older naming method as isopropanol. The idea being that this is an isomer of 1-propanol. And this is rubbing alcohol. So this is the stuff that you buy in the drugstore in the clear bottle to disinfect things. So this is our rubbing alcohol. The proper name is propan 2 all. Okay. So for all of these, almost all of these functional groups, except for the halogens, we're going to be putting indicating the functional group in the suffix, and we're going to be putting the number of where it is, if we need to, also where the suffix is. So that 2 definitely indicates that 2 is referring to the all and not to anything else that might be on that propane. Okay. Now, what if we had, and I forgot to put an extra one on here, so I don't know if this is actually one of the alcohols in your book, but what if we had the exact same thing, but we had a methyl group coming off here. So we have I kind of wrote all these hydrogens out and I made these condensed. But so what would we call this compound that has 3 carbons, the alcohol, and a methyl group? Go ahead, Amaya. You're on the right track, but for the substituents, any branches coming off, we're going to put it at the beginning, not at the end. So the alcohol part's going to be at the end, but the methyl part's going to go in the beginning. So you're going to, before you get to the propan, you're going to put the methyl group at the beginning, like we did for branched alkanes. So how am I going to designate where that methyl group is? Yeah. So we're going to start with 2-methyl. And then we're just going into here, propan 2-ol. So here we've got our prefix, which is a substituent. We've got the root, which also includes whether it's an ane, ene, or ine. Okay, so that propan would be a propene if it also had a double bond. Okay, and then the suffix is going to be our functional group. All right, I think we can do one more. Here, any questions on the alcohols? We'll talk a little bit more about alcohols probably tomorrow. Okay, carboxylic acids. So these also have a general formula, and this is the thing that you're looking for in a condensed structural formula that tells you you have a carboxylic acid. It's going to have that COOH at the end. Okay. And this is also going to be pretty straightforward. It's going to be our root or our stem, our AN, EN, or YN, and then the suffix is oic acid. So this is methanoic acid, ethanoic acid, propanoic acid, butanoic acid. Okay. And the same thing is going to be true on the second line here when we have a branch, when we have a substituent branch. That's going to go in the prefix, okay? And when you have something like carboxylic acid, your numbering is always going to, the functional group is always going to take preference over any branches. So the carbon number for this, the carbon numbering, carbon number 1 is always going to be the one with the, that's part of the carboxyl group. Okay, so that's always going to be carbon number 1, 2, 3, 4. So this one would be 3-methyl. And that's going to be our prefix. And then butan is our root plus our bond situation. And then our suffix here. So the suffix is our functional group. Our root is going to be our carbon chain and bond type. You can also kind of put the "an" as part of the suffix, because since that is technically a functional group as well. I always think of it as being part of the root. If it helps you to move it over, feel free to think of it that way. This is going to be our substituents, which is the same thing as our branches. Okay, so we're going to have branch, root, and then branch, stem, and then suffix is going to give us the functional group. Okay. All right, we'll do a few more of these tomorrow before I give you the practice stuff to work on, and then you can also practice by naming everything in this booklet, in this study guide, including the ones that we did on page 8. You can also go ahead and name those to give yourself a little extra practice.